Bismillahirrahmanirrahim. Assalamu alaikum students. In the last lecture, we were discussing dot product or scalar product. We said if we have two vectors, non-zero vectors, A and B, and if phi is the angle between them, then A dot B is defined as magnitude of A, magnitude of A, magnitude of B, the cosine of the angle between the vectors. Then we explained it and we give an example. We said in physics we express many physical quantities which themselves are scalars expressed as dot product of two vectors. As we said, work done by a constant force is expressed as W is equal to F dot S, where F is the force, constant force acting on some particle, and S is its displacement. So this example we discussed. Now, this is one way of finding the dot product of two vectors, that you have to find the magnitude of the two vectors and you need to know the angle between them. Then using this definition, you can solve for the value of dot product. Now, there is another way. If two vectors are given in unit vector notation, for example, if A is given as AXI cap plus AY J cap plus AZ K cap, and another vector B is given as BXI cap plus BY J cap plus BZ K cap, and we are asked to find dot product A dot B. So we substitute them in the unit vector notation. So my A is AXI cap plus AY J cap plus AZ K cap dot with BXI cap plus BY J cap plus BZ K cap, right? Now if we expand this, on my right hand side I will have 9 terms. This term multiplied by these 3 will give me 3 terms. This AY term multiplied by this bracket will give me another 3, and this term multiplied by this bracket will give me another 3 terms. But 6 of them will vanish, they will become 0, because either they will have I dot j attached with them, or j dot k, or k dot I. You can check it. I dot j, j dot k, k dot I are all 0, because angle between ij, jk and ki is 90 degree, cos 90 is 0. So only 3 terms in this will remain, which will have attached I dot I, which is 1, j dot j, which is 1, k dot k, which is 1. And those terms will be ax bx plus AY PY plus AZ BZ, right? So if two vectors are given in unit vector notation, you can directly from the components find the value of their dot product. You have to multiply the corresponding components, then you have to sum those products, right? So this is one way of finding the dot product. This one way, this is another way, right? Next, we have cross product or vector product. Right here, multiplication of two vectors to yield a vector, right? So in vectors, we define another product called the vector product or cross product. Cross because we represent this operation by cross. Vector product because this product yields a vector. Now we go to its definition. Again, if we have two vectors, A non-zero vectors, A and B, having angle phi between them, then A cross B by definition is a vector. So if it is a vector, then it will have a magnitude and a direction. How to find or what is the definition? How we define the magnitude and direction of this A cross B vector? First we discuss its magnitude. Then we move to direction. So magnitude this way. Magnitude of A cross B. So this is, we are talking of magnitude. So magnitude of A cross B vector by definition is magnitude of A into magnitude of B in the sine of the angle between the vectors, right? So this is the definition of magnitude of A cross B. Now you can interpret it differently also. Either you can say it's product of three things, or you can club B and sine theta into one thing. What is this? This is component of B perpendicular to A, perpendicular to A vector. How can you find it? So this is your A, this is your B, and this is your phi. You draw perpendicular from B, right, on A. You know, this is B cos phi, or this thing, this length. This is B sine phi, right? This is B sine phi. This is, this thing is B cos phi, as we already know, is called component B along A. B sin phi is called component of B perpendicular to A. You can say either magnitude of A cross B is magnitude of A, magnitude of B into sine of phi, or you can say it is product of two things, magnitude of A into component of B perpendicular to A. Or you can write it this way also, it is product of magnitude of B into A sine phi, and interpret A sine phi as component of A perpendicular to B, right? So this is the definition of its magnitude. What about direction? Now I move to direction of A cross B. What is its direction? If this is my A, this is my B, and this is angle phi, direction of A cross B is, by definition, A cross B is perpendicular to both A and B. Perpendicular to both A and B, or that means, or perpendicular, or where is my pen? Or perpendicular, 1 minute. This is my pen. Or perpendicular to the plane containing A vector and B vector, right? So direction of A cross B is perpendicular to both A and B, or I can say it is perpendicular to the plane containing A and B. For example, if these vectors A and B are in the plane of both my whiteboard, then A cross B vector is perpendicular to this board. When it is perpendicular to this board, it will be automatically perpendicular to A and B both. Now question is, if it is perpendicular to board, there are two possibilities. Either it is outward coming out of the board, or it is inward coming into the board. How to decide that? For that we have the right hand secret rule. What is right hand secret rule? It says, so you know secret, we have secrets, right? Now secrets are of two kinds. What is right hand secret? Second is left hand secret. Right hand secret is, if you, for example, if this is the face of right hand secret, if I rotate it clockwise sense, it will advance in forward direction, right? If I rotate it in counterclockwise sense, it will move outward, it will move back. So right hand secret rule says, assume These vectors are on the face of this right hand square. Now what you do, if you have to find the direction of A cross B, you push the first vector, that is A here, towards second vector, that is B, but through smaller angle, not this way, that means this way, not this way. I will cross this, not this way, this way, right? So if you have to find the direction of A cross B vector, assume these two vectors are on the face, this plane of this. This is the face of this vector. This square, I will use some color. Assume these vectors are this way on this face. This is your A, this is your B, at this angle. Now you have to push vector A towards vector B through smaller angle. And what will happen? This square will move in here anti-clockwise sense. When it will move in anti-clockwise sense, what will happen? Square will come out of the board, right? It will come out of the board. That means A cross B vector will be pointing out of the board. The rule is push the first vector in the cross product towards the second vector through smaller angles and see the advancement of the right hand square. That direction of advancement of the right hand square is the direction of A cross B. So I write it here. Push the vector A in general first vector in the cross product. Push the vector A towards vector B through smaller angle. Then the direction of advancement of the right hand square is the direction of A cross B. Got it? So A cross B vector is perpendicular to A and B both. And how to get its direction? Push the first vector towards the second vector through the smaller angle. Then the direction of advancement of the right hand square is the direction of A cross B. Here, when I push A towards B through smaller angle, this right hand square will come out of the board. So my A cross B is out of the board. That we indicate, let me use this color, that we indicate by dot. Dot indicates the tip of A cross B vector. So A cross B vector here is pointing out of the board. Now, if I have to find B cross A, try to understand it. Its magnitude will be same as magnitude of A cross B vector. But what about direction? To find the direction of B cross A, you have to push B towards A through smaller angle. So when you push B towards A through smaller angle, right hand square will move into the board. So B cross A will be pointing into the board. That means it will be indicated here by cross. Cross indicates the tail of the vector. So A cross B here is out of the board. B cross A is into the board, indicated by cross. A cross B indicated by dot. That means A cross B and B cross A vectors have same magnitude but opposite direction. In vector terminology, that means A cross B vector is minus times B cross A. They are antiparallel vectors, oppositely directed vectors. So we say cross product is anticommutative. Cross product is anticommutative. But dot product, in case of dot product, A dot B is same as B dot A. So there we say dot product is commutative. Okay. First I said the magnitude of cross product is given by this, right? Then I discuss its direction. Now I'm saying cross product is anti-commutative because of this minus here. I write this here also because A cross B is minus times B cross A, right? But dot product is commutative. Now another thing, if you look at this magnitude of A cross B, which is A B sine phi, what is it geometrically? I write, then I will explain. This magnitude of A cross B vector is actually geometrically, it is the area of a parallelogram with A and B as adjacent sides. Saying magnitude of A cross B vector geometrically is the area of a parallelogram with A and B as adjacent sides. See how? If this is my A, this is my B. You know, parallelogram is a four-sided figure with opposite sides parallel and equal in length. So if we complete this parallelogram, it will be like this. So I completed the parallelogram. If I have to find this area, I name this area. This is area A. Yeah, area. Just I will write just area. This area is simply base. Base is magnitude of A. Then multiplied by the altitude. This is altitude. And you already know this altitude, this length, but you can see this length. This is one and the same thing. This length is B sine phi. This length is B sine phi. So area of this parallelogram therefore is magnitude of A into magnitude of B into sine phi. So this is base, this is altitude or height, right? So it is justified that the magnitude of A cross B vector is geometrically the area of a parallelogram with A and B as adjacent sides. So A and B are here, tail is adjoining. So they are adjacent sides, not opposite sides. Got it? Next thing is, if now see A cross B is a vector, any vector has unit vector notation, so it will have a unit vector notation. Dot product is a scalar quantity, it will not have any unit vector notation. Now if I am given two vectors as in unit vector notation as ax I cap plus ay j cap plus az k cap, and another vector is given as bx I cap plus by j cap plus bz k cap. Both are three-dimensional vectors, and I have to find A cross B vector, right? Directly from components. I've already discussed one way. You have to first find the magnitude of A, then magnitude of B, then angle between A and B, smaller end, and then you can find from this formula its magnitude, then use right hand sector tool to find the direction. But there is an alternative method. You can directly use components, but you have to expand this determinant. You write first in this determinant in the first row I cap, j cap and k cap. And in second row you write the components of first vector in the cross product. And ax below I cap and ay below j cap, az below k cap, and then the components of second vector bx, by, bz. When you expand this determinant, you know how to expand the determinants. That will give you the unit vector notation of this A cross B vector. So you have two ways to find the A cross B vector. One is directly from components, second is which we discussed before this. Next thing, we talk about unit vectors. Remember, we already said that we have three spatial unit vectors. I cap unit vector is a unit vector along positive x. J cap is unit vector along positive y, and k cap is unit vector along positive z. Now if I have to find I cross I, it is zero vector. Why? Because angle between I and I is zero, sine zero is zero. So we write it zero. Well, likewise, J cross J is zero, K cross K is zero. So we club this, we write I cross I. Because of angle 0, sine 0 is 0, right? I cross I is J cross J is K cross K, all are 0. So you need to remember this, right? Then let us discuss, if I cross I with J, what is I cross J? I explain here. Its magnitude will be magnitude of I, magnitude of J into sine of the angle between the I and J, that is 90. Sine 90 is 1. That will be 1 into 1 into 1 This is 1. So magnitude of this vector is 1. I and j are dimensionless. So this vector will be also dimensionless. What about the direction? Right hand secret rule. I have to push I towards j through smaller angle. Secret will come out of the board. That's along z. Along z, the unit vector is k cap. That means I cross j is k. Similarly, j cross k is I. You can figure it out. And k cross I is j. You need to remember this also. Let me this color. So I cross j is k. J cross k is I. K cross I is j. Can you tell me what is j cross I? It will be minus k. Because we change the order, minus will come here. As I said, that cross product is anti-commutative. So j cross I will be minus k. What will be k cross j? K cross j will be minus I, right? J cross I minus k cross j minus I, and I cross k will be minus j. So you need to remember this. Now simply change the order here. I cross k minus j. J cross I minus k cross j minus I. All these things you need to remember. This finishes our revision of vector algebra. I will give you some questions as your homework. Or I will give first one example of cross product. Let me give one example of cross product. Which color I use? So example for cross product, right? Now for dot product we said W is written as F dot S, right? Now cross product is a vector quantity, therefore the physical quantity which we express as cross product of other two vectors must be a vector quantity. And one example is here: torque about a point due to a force. Torque is a quantity. It was defined about some point, and it is due to some force. You have done it in your 11th class. I revise here. So let this be x, this y, and this z. Let O be origin. Now if I have some particle having mass m, now some force effects on it. I want to find the torque of this force on this particle having mass m about point O. What I do, I have to take a vector r from point O to the particle. Then by definition, torque on mass m due to force F about point O are denoted by tau is given by. So its definition is tau is R cross F. Let's express it as cross product of R and F. So I repeat, I have a particle of mass m, some force effects on it. Then I have to if I have to find the torque on this mass due to this force F about point O, it is by definition R cross F, right? So all rules of cross product will be applicable to it. Its SI unit will be Newton meter. Is a vector quantity. It will be perpendicular to R and F both, or perpendicular to the plane formed by R and F. And to find which way it points, you have to use the right hand circular rule. And you know its magnitude will be magnitude of R, magnitude of F, and the sine of the angle between the vectors. And that angle in this figure is not this, but this. This is phi. There are other physical quantities also, which are expressed as cross product of two vectors. We gave one example. This finishes our vector algebra revision. Now I will give you some questions as homework. So homework. Question 1. Question 1. Part A. What is the sum? What is the sum in unit vector notation of the two vectors A equal to 5 5 plus 3j and b equal to minus 3i plus 2j. This part first, then I have part B. So my part B is, what are the magnitude and direction of A vector plus B vector? I repeat the question. Part A is, what is the sum in unit vector notation of the two vectors A equal to 5 pi plus 3j and B equal to minus 3i plus 2j? Part B is, what are the magnitude and direction of A plus B? This question 1. Question 2. My question 2 is, given two vectors A equal to 4i minus 3j and b equal to 6i plus 8j. Find the magnitudes and directions with the positive x-axis of of part A is vector A, part B is vector B, part C is vector A plus B, part D is vector B minus A, and part E is vector A minus B. I repeat the question. Given two vectors A equal to 4i minus 3j and B equal to 6i plus 8j, find the magnitudes and directions with the positive x-axis of part A, vector A, part B, vector B, part C, vector A plus B, part D, vector B minus A, and part E, vector A minus B. Do your homework. Be sincere with your studies. That's all for today. Thank you. Assalamu alaikum. God bless you.